Hello students, in this video let us learn finding Laplace transform of a function. So let us consider this function. Find the Laplace transform of the function f of t, which is equal to mod of t minus 1 plus mod of t plus 1 for t greater than or equal to 0. Now here let us write this function once again. F of t, it is mod of t minus 1 plus mod of t plus 1. Now it is given in terms of mod, and for t greater than or equal to 0. So for mod functions, we don't have any standard Laplace transforms. So try to rewrite this function. So what happens at t equal to 0? Actually, function is defined for t greater than or equal to 0. So what we see is, let us see what happens at t equal to 0. So in this function f of t, if you put t as 0, you'll get minus 1 here. It is mod of minus 1. Again, if you put t equal to 0, we'll get 0 plus 1, that is mod of 1. Now mod of minus 1 is 1, mod of 1 is also 1, so 1 plus 1 will get 2. That implies at t equal to 0, function will take the value 2. Now we'll find one more value of the function, that is we'll put t equal to 1, and now let us see what happens to f of t. T is substituted 1 here, 1 minus 1, it is 0. Then again t is substituted 1, 1 plus 1, it becomes 2. Now 0 plus mod 2 is 2 itself, so you'll get 2. F of t is 2 at 0 and also at 1. And for t greater than 1, for all other values of t greater than 1, what happens to this function? Suppose t is greater than 1, so whatever the value you take, whether it is 2 or 3 or 4, t minus 1 will be always positive. So always positive means even if you remove mod, then also the function value remains as t minus 1 only whenever t is greater than 1. Hence, this first function mod of t minus 1, it becomes just t minus 1. And even mod of t plus 1, for values of t greater than or equal, no, sorry, greater than 1, again it becomes t plus 1 only. Value of f of t for t greater than 1. So if you take any value of t greater than 1, t minus 1 is always positive. So I'll just remove mod and write t minus 1. Similarly, for mod of t plus 1 will become t plus 1. If we add these two terms, minus 1 plus 1 cancels, we get 2t. So thus we'll split this function. We have split this mod function as uh, at t equal to 0, value of the function is 2. Again at t equal to 1, value of the function is 2. And for t greater than 1, function takes the value 2t. Now, we'll, because it is a split function, we'll go for the definition of the Laplace transform. So Laplace transform of the function f of t, it is equal to integration from 0 to infinity e raised to minus st f of t dt. Now, sorry, integration limits are from 0 to infinity, but function is not the same throughout this interval. So what we do is we'll split the interval of integration accordingly. So what we are seeing is from t equal to 0 to 1, function will take the same value, that is 2. So let us write from 0 to 1 e raised to st f of t dt, and again from 1 to infinity. So for t greater than 1, that is 1 to infinity, the value of the function will be 2t. So we have splitted the interval from 0 to 1 and 1 to infinity. Let us substitute the corresponding functions here. Integration from 0 to 1 e raised to minus st, the function f of t will take the value 2 in this interval. So we'll write 2 dt plus in the interval 1 to infinity, again we'll put the value of f of t, which is 2t. Now we evaluate these two integrals. 2 is a constant. Let us keep it outside. Integration of e raised to minus st. It is e raised to minus st divided by minus s. Limits are from 0 to 1. Plus we have 2 is a constant here, and we need to evaluate the integration of t into e raised to minus st. So it is product of two functions, t into e raised to minus st. Will go for the Bernoulli's rule. T will keep as it is. Integration of e raised to minus st. It is e raised to minus st divided by minus s, then minus sign Derivative of t, it is 1. Integration of this term once again. So minus s will be constant here. Integration of e raised to minus st, it is e raised to minus st divided by 1 more minus s. So it is minus s whole square. So we need to take the interval of this integration from 1 to infinity. Now let us put the limits to as it is here. If you put 1, then e raised to minus s it becomes. For t, we are substituting the value 1, it becomes e raised to minus s. And if you put 0, it becomes 1. E raised to 0 is 1. So minus, the lower limit will give 1, divided by we have minus s, plus 2 constant outside. Now if we put infinity here, e raised to minus infinity is 0. Again here also in the second term, e raised to minus infinity is 0. So for upper limit totally both the terms will give us 0. Then minus will put the lower limit 1. T is 1, 1 into e raised to minus s divided by we have minus s. Minus we have again here. So let us bring it down minus. Then again put 1 to this term. E raised to minus s divided by minus s whole square means it is just s square. So let us write all the terms 2 as it is. E raised to minus s divided by minus s, it is written here. E raised to minus s is there, so written here. Then minus of minus, it becomes plus 1 by s, it is written as the first term, plus 1 by s. Then here minus into minus, it is again plus. We have e raised to minus s divided by s. Then minus into minus, it is again plus e raised to minus s divided by we have s square. Now these two terms are same except but for the sign, so they get cancelled, and what remains is 2 into 1 by s plus e raised to minus s by s square. If we take limit, we'll get s plus e raised to minus s divided by s square. So that is how we find the Laplace transform of this modulus function. Thank you.